All right, well, welcome back. What we're going to be doing now is looking at the different types of reactions in a real scenario and seeing if we can identify which ones are give them their types. So what I'm going to first do is I've got 10 equations for you. I'm going to go through each one and identify whether the reaction is one of the 5 types: synthesis, combustion, decomposition, double replacement, single replacement. All right, so let's look at the first equation. This equation has hydrochloric acid reacting with copper. And what you're going to notice is the hydrochloric acid is going to break apart and the hydrogen is going to be replaced by the copper. So copper is coming in, taking hydrogen's place. So this first reaction is called the single replacement reaction. Reaction number 2. In this reaction, what I have is I've got propane mixing with oxygen to make carbon dioxide and water. The key here in this equation is that we've got oxygen. This equation is a combustion reaction. Remember, combustion reactions often deal with carbon and hydrogen mixing with oxygen. Now reaction 3. This reaction has hydrogen and oxygen that are 2 separate molecules, and then finally we get a new product and only one of them. So this equation is called a synthesis equation. Looking at the next equation, there's nothing over there. Well, you're not going to be required to do this, but you might as well learn how to predict what the reaction is going to be. So I have 2 ions right here. I've got nitrate, and I've got silver, and I've got sodium, and I've got chlorine, or chloride. So what this is this is a positive and negative. So this is the cation, this is the anion, here's the cation, here's the anion. In this equation, what we are going to do is we're going to switch partners. This cation is going to go with that anion. So I've got AgCl. And then over here, I'm going to have sodium is going to join with nitrate. Since everybody here, all the ions in this group, have a positive or negative charge, I don't have to carry any subscripts over to complete the reactions. So this reaction, since I've moved 2 different things, this guy went with this one, and this guy went with this one, this is called a double replacement. Now my third reaction, or my 5th reaction actually, sorry. This reaction involves one compound and there's heat, and you're wondering what's going to happen. This is called a decomposition reaction. What's going to happen is I'm going to break these guys apart. So I'm going to write nitrogen and hydrogen by itself. Then I remember from the periodic table that the elements over here on the periodic table, NOF, Cl, Br, and I, are diatomic. What that means is when you write them by themselves, you always put a 2 there. Now I'm going to finish balancing the equation. I have 2 nitrogens there. I've got 1 nitrogen here. I'm going to put a 2 there. Now I've got a total of 6 hydrogens here. I've got 2 right there, so I'm going to give it a 3 there. 2 times 3 is 6. This equation is now balanced. Next question. Number 6. I've got 1 atom here and 1 atom there, and I'm going to do something with them. The only option I have here is a synthesis reaction. I'm going to put them together. Actually, let me go back to this previous equation and write down what type it is. This guy is called a decomposition. That's that guy. Now, going back to the next equation, I've got iron and sulfur, and I'm going to put them together. So, iron and sulfur. The most common form of iron in this case is iron plus 2, and sulfur has a -2 charge. Therefore, the plus 2 from iron goes down there to the sulfur. Sulfur has a -2, it goes down there. Since they're both the same number, I cancel them out. This equation is a synthesis equation. Let's go to number 7. Now number 7 is a little more complicated. It looks like there's a little more stuff involved. On this equation, what you should notice is that you've got one metal here, and then you've got 2 ions over here. This is a positive, and this is a negative. Okay, this whole sulfate has a -2 charge. This hydrogen has a +1 charge. What's going to happen is, this is a cation also. This guy will come in and replace the hydrogen. And as you see that, the zinc and the hydrogen have swapped places. So we get zinc with sulfate and hydrogen by itself. Now zinc has a +2 charge, so the +2 on the zinc and the -2 on the sulfate go across and cancel each other out. Finally, when you see hydrogen written by itself, once again, you go back up to the rules about the diatomics, NOFClBrI, and one other, the hydrogen, way over on the other side. So since hydrogen's by itself, we're going to give it a 2. Now I'm going to move on to the next equation. I've got 2 elements here, magnesium and oxygen. Because of that, this is going to form another, so this guy right here, I'm sorry, this is a single replacement. Let me switch my pen. Going on to the next equation. This equation has 1 magnesium and an oxygen gas. Okay, since there's only two players, this equation is going to form something called a synthesis reaction. We are going to take these 2 and mix them together. To do so, I have to first look at the periodic table. Now the periodic table has a chart, shows that magnesium has a +2 charge. Now oxygen, when it's in an ionic form, it has a -2 charge. The -2 and the +2 from these come together and cancel out, so what you end up with is just MgO. To balance this, once again, if you wanted to, you could put a 2 there, and you've got that side is balanced with the oxygens, and I'm going to put a 2 over here. Now this equation is called the synthesis equation, or synthesis reaction. All right, my next equation. This involves one thing breaking down to 2 other things. Since we start off with 1 reactant and 2 products, this is called a decomposition reaction, even though it doesn't fit the traditional form. This guy started off with one compound, broke down into 2 different molecules. All right, so on this one, what we've done is we've broken them apart, we've done some different things. I wouldn't require that you predict the products of this. What I would require is that you determine what type of reaction it is. Since we started with 1, we ended up with 2, we're going to call it a decomposition. To balance it, I've got 2 aluminums there, I've got 1 here, so I'm going to give it a 2. Now let's look at the hydrogens. I've got 2 times 3 is 6 hydrogens on this side. And on this side, I have 2 hydrogens. So I'm going to give this guy a 3, because 2 times 3 will now be equal to 6. That 6 will equal, or will balance out with this 6 on this side. Now I move on. I look at the other players. How many oxygens do I have here? I've got 2 times 3 is 6 oxygens there. I've got 3 there and 3 more. So now my equation is balanced. This is a decomposition reaction. Now finally, in this equation, I've got some different things going on. These guys kind of stand out because this is called the double replacement reaction. Why is this called double replacement? Because this cation is going to bond with that anion over there. And you'll see this anion bond with that cation. So they are swapping. So this calcium is going with that nitrate, and this mercury is going with that iodine. What you'll notice is that the positive ion, the cation, is always written first. Whenever you write equations or formulas, you always write the positive ion first. All right, so this guy, since we've got all these different things, I drew 2 different lines. This is called a double replacement reaction. Hopefully that's been helpful for you. If you'd like, we can go back to the top and balance the equations. Let's just check. I've got 1 chlorine there. I've got 2 chlorines over there. So I'm going to come over here and put a 2 right here. Now I've got 2 chlorines, 2 chlorines. I've got 2 hydrogens and 2 hydrogens there. Therefore, this equation is now balanced. Going to number 2. This is a little more complicated. I've got 3 carbons there, and I've got 1 carbon there, so I'm going to put a 3 there. When I balance equations, I always start off with the element that occurs on both sides only once. The element that occurs on both sides multiple times, I avoid as much as I can until the very end. Looking over here, I've got 8 hydrogens there, I've got 2 hydrogens there, so I'm going to put a 4. So now I have 8 hydrogens. Finally, I look at my oxygens. I've got 2 on this side, but I've got 2 times 3 is 6 there, plus 4 right here. 6 plus 4 equals 10. So over on this side, I'm going to put 5. So now I have 5 times 2 is 10. This is a balanced equation. Going to the next problem. This synthesis equation is already balanced, as you can see. Looking over here at silver nitrate and sodium chloride. Since everybody has a positive or negative 1 charge, the equation is already balanced when I wrote it out. And it looks like the rest of the equations have been balanced also. I hope this was helpful for you.